All right, so thank you for being here. My name is Chelsea Simmons, and I am the Education and Outreach Coordinator for Share Environmental Action Team, also known as BEAT. I'm really excited to get to Tom's talk, but I'm going to go just share a little bit about our organization. So if you don't already know us, you can find out a lot more about BEAT on our website, thebeatnews.org. Our mission is to work together to protect the environment for wildlife in support of the natural world that sustains us all. On our website, you can easily stay informed about environmental events, job openings, public meetings, and projects that are taking place in Western Mass and regionally. We have a community calendar where we compile other environmental organizations' events that they send us into one convenient place. And then we also have a jobs board that has local and regional environmental job postings. And then twice a month, we go through the state's environmental monitor and list the big projects that we should all just be keeping an eye on for the Berkshires and the Connecticut River Valley, and then statewide as well. And we also have a page of public notices for Berkshire, Hampshire, Hampton, and Franklin counties, mostly about Conservation Commission meetings, but there are other environmentally relevant ones as well. And that gets updated every week. And then everything I just mentioned can actually be found on our weekly e-newsletter, the Beat News, which also has articles about local, regional, national, and global environmental news. If you'd like to subscribe to the Beat News, you can go to this news and calendar and then the current weekly newsletter page on our website and just click subscribe. All right, so many of you probably already know this, but BEAT is a 501c3 nonprofit. So that means we get all of our funding through donations and grants. So programs like this one are possible thanks to everyone who supports BEAT. If you'd like to donate to BEAT, there's a donate button up here on our website header that makes it pretty easy to do so. And thank you. All right. And then we have a lot of upcoming events in the next several weeks, and a lot are actually in person, it's pretty exciting. Tuesday, May 17th at 6 p.m., Joan Edwards, who is a professor of biology at Williams College, will speak about the impact of biodiversity loss of flowers and their pollinators, and also go into how the dynamics of flower pollinator networks can help to conserve both. And then on Saturday, May 21st, we, along with Housatonic Valley Association, Berkshire Regional Planning Commission, and the City of Pittsfield, will be celebrating World Fish Migration Day at the Berkshire Athenaeum, the Pittsfield Public Library. And there's going to be lots of cool and interactive displays, activities for kids, and then there will also be some presentations along with videos, and that'll be it'll start at 10 and the presentations start at 10:30. And then later that afternoon, the same day, we are having an open house at our Environmental Leadership and Education Center. And then Saturday, May 28th, there will be a Westside Block Party hosted by the Westside Legends, and we're going to be doing our Kids in Kayaks program there, where we teach kids how to kayak in the Housatonic River. Anyone's welcome, everyone's welcome to join in at the Westside Block Party. It's Memorial Day weekend, so it's a great time to, go out and about and have some fun. And then the following weekend, on June 4th, you can catch us at the Berkshire Pride Festival and Mass Audubon's Family Fun Day. And then the very next day, we're doing a river cleanup by canoe and Linux with Housatonic Valley Association. And lastly, we plan to have a tag sale at BEAT's Environmental Leadership and Education Center to help raise money for BEAT so we can keep planning events like this one and all the ones I just mentioned. And now I've talked long enough. I'm going to stop sharing my screen and hand it over to Tom Tyning. All right, Tom, I will let you introduce yourself. Thank you
Great.
for being here.
You're quite welcome. Let me make sure I can share my screen. And I apologize for holding you up for a few minutes beforehand, Chelsea. You probably have invented 2 or 3 new gray hairs because of me. They don't show yet, but I apologize for that. My
No,
computer
it's
at home
okay.
here is a little slow for some reason, and I don't know why. But let me first share my screen. But looks like there's a lot of names that I am familiar with on your list here, and beet, of course, is one of the important and fabulous kinds of organizations that there are. I'm a former board member of beet when it started 100 years ago. At least it feels that way to me. I don't know how Jane keeps it going, and Chelsea, you're going to have to really get flying to keep Jane happy. We all should keep Jane happy. That should be our goal in life because she does such great work, and so does beet. So anyway, welcome everybody. Happy to see you. And when Chelsea asked me about doing a presentation about this, I'm assuming, Chelsea, you can see my screen. Is that working? Okay. Uh, the idea of streams and brooks and rivers and estuaries are all connected. But I think we forget about a lot of this connection because, we go to Greylock, we hike around in there, we look at things. Yes, there's some waterfalls when the snow melts and the spring rains are there, but you have to understand that every single drop of rain, every bit of water that comes off of a tree leaf, every bit of water that comes out of the urinary tract of a deer, every bit of water goes to something. And that something is what we generically call watersheds. And watersheds is the big name most of you are familiar with that include a major river and all of its tributaries. Now you can find lots and lots of maps about our region all over the place. This is a nice Berkshire Taconic map here on the left that shows the mountain ranges, and these are very important. Look at the Taconics down there in the Berkshire Hills and the Green Mountains connecting up there. But if you look at the right-hand side here, this is a map of the Westfield River. And the Westfield River starts in Berkshire County. It starts in these Berkshire Hills that we have. And while most of us talk about the Housatonic or the Hoosic Valley, and we talk about the hill towns, you can't have the Housatonic or Hoosic Valley without the hill towns. Not at all. And in fact, I'm trying to find a student at BCC where I teach, for those who don't know me, try and develop new state, county, and town boundaries based on watersheds, not on these artificial straight lines or this weird thing down here in Southwick. Where in the world did that come from? And this little piece that was cut off from Copake Falls that used to be part of Massachusetts, it's now been excised some time ago. Very, very fancy. Why in the world have we not ever considered making political boundaries that were based on watersheds? This could be the county of Westfield that would include some of these hill towns that we have here, as well as towns in Franklin, Hampshire, I call it Hampshire County, where I used to live, Hampshire County, and Hampden County. And it's great that beet includes all of these things because beet is really utilizing the mentality of watersheds. It's all really important. And none of it happens without this stuff. Now, I'm just going to tell you some stories here about some of the stuff that that we're doing.
Want to bring that up?
Oops, sorry. Oops, sorry. So, the big rivers, Connecticut River, the Housatonic, all of these have smaller rivers that we have all around here in the Berkshires, and we go to them. They're spectacular, they're magnificent, but you can't have these without all of these streams that start up in the hills. These tributaries completely fill these rivers. Without these tributaries, these rivers would basically run on groundwater, which is being depleted dramatically, and even the Connecticut River would have a hard time running if it wasn't for tributaries. This is what I'm talking about, and I took, oops, come back here, sorry, bad touch. I took these pictures yesterday in the rain on the Westfield branch over in Windsor. And here is a spectacular look at a couple of things. One is on the right here is this picture of what is called now a first order stream that empties right into the Westfield River. And when I say a first order stream, you'll see a picture of this in just a second or two. And some of you may be more familiar with these these order stream numbers than I am, but so feel free to say something. On the left here, this bigger picture, here is another small tributary that's just joining in to this first order stream just as it enters into the Westfield River. What's more important, the Westfield River or these little dinky tributaries? My contention is they're both equally important. Certainly the Westfield River, certainly the Connecticut River, the Farmington River, the Housatonic River, certainly these are important big rivers for sure, but they are not disconnected, and we can't think of them as disconnected from the rest of the world, including and especially these little streams. There are two things, and I think Jane brought this up to me, and probably Chelsea as well. One of the problems we have with these small little streams is that some of them don't flow all year round. They're intermittent streams, and this one on the left is at Pittsfield State Forest. Nice spring water coming down there. In midsummer, it's dry. You could lie down in this and not get damp at all. Well, you might get a little muddy, but there's no water running. This river access to water, whether it's intermittent or perennial, is a real difficult issue for conservationists. It's been a big issue for the critters that live in these places, for sure. And it's exceedingly important to know that these rivers and these small streams have groundwater input. They've got upper sort of ephemeral wetlands that ooze down water, of course, snowmelt, rain itself. All of this contributes to these. However, most people have been looking at these streams and trying to decide just how in the world do we decide what kind of a member of the watershed they are. Are they really important or not? A couple of biologists here, friends of mine, some of you know Bill and Joe from down in the valley, who are with me in Plainfield here looking for salamanders in midwinter. Those nets freeze within 13 seconds of being taken out of the water, and I think the temperature this day was something like 22 degrees. The water was flowing, at least parts of it were flowing, and we're looking for salamanders in midwinter, and it's perfectly reasonable to do that. So maybe it's not that reasonable, but it was something to do. If you look around the internet, you will see some spectacular maps and information about these small streams, these upland streams, these forest brooks, as they're called, in dozens of different ways. This is a map of cold water streams in Massachusetts, and look at where they're concentrated. The hill towns of Berkshire County and throughout the Berkshires and the higher elevations in Hampden, Hampshire, and Franklin County, and even into Worcester County. These are cold water streams, and this is sort of the topic that we're talking about today. The critters that I have been looking at in recent years, even though I spent a lot of time in vernal pools, a lot of time even in the main stem of the Connecticut River, it's these cold water streams that have gotten a lot of attention in just the last few years, because the question is, how cold will cold water streams be as climate change continues to grow on us? Just for a brief introduction, these two diagrams on the left are two of the most commonly used methods of identifying streams, and they're called stream orders. Really, the first effort to do this was in the 1850s or so. A spectacular ability to try and say, what is a river, what's a stream, what's a brook, what's this and that. We have dozens of common names, but in order to really understand these and to study them, people have developed different methods of measuring these or counting them. On the left, the Strailer Method, on the right, the Shreve Method. These are both the two common ones that are used today, and if you at all get into GIS mapping, which is a common program in a lot of universities, including BCC. In fact, Jane's husband will be teaching GIS next semester, I believe it is, or the semester after at BCC, I think next semester. And GIS mapping is really requiring lots of good information. This method on the left is, both of these I should say, the bottom colored arrows, the yellow here and the blue here and the purple there, are really the main parts of a river that dump into the ocean. If you go upstream, which is north in the picture here, in either one of these, you have different small little branches. That's why we call them branches. They look like Darwin's drawing of what I think might be happening with evolution and natural selection. These branches are all of these streams that are found up in and down valleys. They feed into each other and then feed into the main branch of each river. The Strailer Method is a little simpler to me. A tributary is given a number, 1, 2, whatever it happens to be, based on how many tributaries it has coming into it. So if you look at all of these on the left here, this is one tributary. It has nothing else coming into it, so it's a number 1. This number 1 tributary is flowing where they meet. That next section is called number 2. Here's a number 1 over here, and a number 2, you just don't add it in the Strailer Method. You leave it as number 2. However, as 2 of the same number hit each other, you add 1, number 3. This method of counting, a little bit different in the Shreve Method. It's simply where you do add a 2 and a 1 together to make a 3 and a 1 to make a 4 and a 3 to make a 7. This is just 2 different methods. They're both valuable, and they're both used in modern GIS mapping and effort in federal and state agencies. Either way, these stream orders, that's what this is called, stream orders, are a way to measure a lot of things, and they are especially good, especially the Strailer Method is especially good at modeling stream activities. And these stream activities, I'm going to say 100 times here, and simple to most of you, are not just about the water. It's about the landscape in which they are flowing through, especially these streams. I'll show you a couple more pictures. So whichever one you use is fine. By the way, the largest stream order in the United States, of course, is not a surprise. It's the Mississippi River, and it is a stream order 10. So that is, I think that's under the Strailer Method, and that is a largest one. The Amazon River Basin on the planet, the largest, most complex river system, has a stream order, I think, of 12. So that's as big as they get. Mostly what I'm talking about are these streams that are 1 and 2 orders. People have done a fair amount of work trying to identify the various ecological interactions between these stream orders. This is stream orders 1 all the way down to 12 here at the bottom. And you can sort of get a hint here about the different types of levels of interaction in these ecological communities. Microbes are a really big part of these first and second order streams. There are things called collectors that collect a lot of and gather a lot of things like microbes and mosses and things. Predators like these Dobson fly larvae perhaps, or others that eat everything else that moves. Then there's grazers that feed on algae or even mosses that might be partly underwater. Shredders that tear apart food and get some of their nourishment from smaller particles. It gets different when you get down and take a look at some of these pictures on the left. When you get down to the big giant rivers, you've got things like catfish in there. when you're up in the number 1 levels, these cold water streams are only available to certain groups of organisms, that certain groups of vertebrates that can deal with, maybe not deal with, that require really cold conditions and really high oxygen. And the only fish that we have here in Berkshire County that is a cold water first level, first order stream fish, sometimes second, is the native brook trout. Not these giant things that the state keeps dumping into lakes and such, but these native brook trout require these first order streams. They are the top predators, sort of. The reason I'm saying sort of is because there's a couple of other top predators in here that happen to be salamanders. And so here's a look at these streams again. They are coming out of, they're in forested areas if they haven't been logged. They are relatively clean if ATVs and off-road other things have not driven through them. One of the saddest things I see at Pittsfield State Forest and elsewhere are places where these off-road people are just pouring through these and they're digging up all this substrate. These waters are clear. You can see to the bottom. There are sections where there's little rivulets and flowing of small little waterfalls, and then there's these quiet pools. Both of these are two of the broadest of the microhabitats in these places, and the animals that I'm after are particularly interested in the salamanders there. But certainly the fishes and all those little aquatic invertebrates also utilize either the stream channel itself, where the water is really flowing fast, or these slightly quieter pools where the current is off of it a little bit. Both the fishes and the salamanders and even the invertebrates will utilize different parts of these little cold water streams, different times of their life cycles. So yesterday I was out there with a couple of folks. We were turning rocks, and you see all these stupid little pebbles kind of glommed onto there. You say, what, who glued these things on there? And if you look up to this other picture here, way in the tip top, there's this sort of, why are these little sticks, but mostly pebbles, sitting here? And of course, this is one of the great things about learning about invertebrates, and especially insects. These are caddisflies that have made houses. Now, most of you, if you've done any kind of work with vernal pools, you know there's giant caddisflies that make these big, heavy-looking houses out of sticks and twigs and leaves, and they're fantastic. You couldn't have one of those species in the stream because they'd get blown away by the current. The current is moving so fast, these insect larvae that make these things would have to have heavy houses on them. Their homes, these caddisfly houses, have to be massive. Here's one here that is in perfectly good shape, and the right-hand picture shows you the finger, and that's the size of these things. There is a live insect larvae inside there, and it is crawling along the underside of rocks. So we picked this rock up yesterday, and this is one of many of these caddisflies that basically, it's not really glue. They do have adhesive, but it's mostly a silk that they manage to build a very specific type of house, specifically out of pebbles of a certain size. From what I understand, when I took an entomology course about 300 years ago at UMass, there is apparently a species of caddisfly out west that particularly likes to pick up flakes of gold to make its caddisfly house. Why are we not breeding that thing and getting it out here? Maybe that's something Beat could be doing soon, find this gold-loving cat. At any rate, let me get off of that story. Caddisflies. These are eggs of, I believe, a snail, an aquatic snail down there. They're very jelly-like, and it's hard to see some of these other things that are in here too, so I won't bother with those. But lots of great stuff. Now, here's the big deal about cold water streams. Of course, by far the most attractive to most people and the most well studied are these fishes. And this is a native brook trout that's very, very small. This is full grown. This is how big they are. The things that they dump into lakes and rivers are all basically handmade fish that are grown in large containers and overfed, so they get to be 2 to 3 feet long. The native brook trouts are 8 to 10 inches long in adult size. They can get a little bit bigger, or they can be a little smaller. On the right here is a newly hatched brook trout that we found yesterday in a little pool alongside that stream. So that particular spot is pretty neat, and I'll tell you in a second why we went to that particular spot yesterday. So brook trout are sort of the famous parts of that, and in fact, they're really famous because a huge number of research projects have started, even back in 2015, to look at climate change and cold water habitats, in particular for brook trout. Of course, trout are among the most attractive and highly sought after fish in the world because so many people want to catch them. The incredible amount of money, the millions and millions of dollars spent on fishing gear, fishing equipment, is really designed for specialized fishes. The trout in general, particularly brook trout, are way up there. And so researchers have been spending enormous amount of time, and they get enormous amounts of funding to study fishes. And just in the last few years, people have started to look at what's likely to happen to brook trout populations in these first order streams and second order. They can get into third and fourth order streams on occasion, but they need cold, pure, minimally changing pH water, without which they don't have the oxygen they need. These are highly dependent on a great deal of oxygen, as I've said. There's other totally cool fishes in there. Several species of minnows and the, oh my God, what's the name of this one? I forgot. The Slimy Sculpin. One of the great things, this thing sits on the rocks at the bottom because of it's a little round for a stream species, but still better than a pumpkin seed. They are still elongated, these sculpins, but those two front pectoral fins glom onto rocks so they don't get washed downstream, and they have their mouths at the bottom of their face so that their mouth is already on the substrate and feeding on anything. So this is a slimy sculpin. So I want to let you know there's other species of fish in there. This is a photo I took yesterday through the water. So I'm standing above the water and I'm just photographing down. You can see there's virtually no mud, there's no sand, there's some gravel, but because of the volume and the energy of the stream flow, it clears up all of this stuff that and sends the smallest particles further down to second, third, and fourth order streams. This is what keeps these streams incredibly beautifully clear. Here's a cluster of those caddisflies under another rock that we turned. Now, the salamanders that I'm talking about are big salamanders. And you might be thinking, well, I've seen salamanders. In fact, today, I'm sure if you walked out this morning, you'd have seen a lot of these fluorescent orange, bright red salamanders, thought to be a different species that it turns out to be because when they're adults, they're green and they live in ponds and lakes. That's called the red spotted newt. But once they hatch out of their eggs in late summer out of a beaver pond, they come out on land, lose their gills, turn fluorescent orange, develop lungs, and live 15, maybe 20 years as this juvenile form, the red eft. Then, at the end of that period, they migrate somehow back to a pond or a lake, a beaver pond, dive in, turn green, and live 15 to 20 more years as adults. It's an incredible story. Reddish. This thing on the right was a salamander found at Pittsfield State Forest about 18 years ago. It's a Jefferson salamander that is made up of virtually all female populations, all females in a population. They have an extra set of chromosomes, and this was a yellow albino pinkish one that I've never seen before. I think Tim Flanagan is the guy who actually found this one. It was very, very cool. Now, salamanders come in lots of different shapes and sizes. The biggest salamander that we have here is called the mud puppy. This thing on the left is in a pie plate, and that pie plate is 14 inches long. This is a massive animal that never comes out of water. Now, this is a 4, 5, and 6 order stream animal. It's not the cold water stuff we need, but when the Connecticut River is part of it is drained in Turner's Falls every fall. I've been going down there with several other people, and these things are trapped and get suffocated by the dozens, sometimes by the hundreds, and we'd like to take these out and release them. 2 places in Berkshire County have seen these, Stockbridge Bowl and the pond down near Sandusfield have seen these things. Nobody knows enough about these things to know what in the world they're doing, what they really do, but they never come out of water, completely aquatic. But they get to be 1.5 feet long. That is a big salamander. The stream salamanders that I'm really focusing on are a couple of species. This is called the Dusky Salamander. They're only about 3 to 4 inches long. And they can be really dark with some speckling. They can be kind of a tannish brown as well. But here's how to identify them. Their hind legs and their front legs, if you compare them, the hind legs are massive, 2 to 3 times fatter than the front legs on the Dusky Salamander. These live along these first and second order streams, especially where it has flattened out a little bit. Not so much the cascading down, but in little flat spots. They love that. And then they will lay their eggs on land next to the stream under a rock. And here is a female on the right side who's excavated a little cavity under a rock at the stream edge and laid her eggs, and she stays with them until they hatch up to 1.5 to 2 months later. These little larvae are aquatic, but she put the eggs on the edge of the stream, not in the brook, and so she has to dig them a channel to either have them follow her out, or the water comes in and brings them back out, and they stay as larvae for about 1.5 years. They need a permanent cold water stream to survive in. The other weird thing is a few years ago, and that next to that one that I just showed you the eggs of, I found this yellow albino dusky salamander, this bright color thing. Now, you may have recalled, and you may know already, that those first 2 bright red salamanders I showed you, the juvenile form of the redback salamander, the red spotted newt, the red Fs as we call them, are incredibly toxic. It's possible that these color forms of Jefferson's, this dusky salamander that's yellowish reddish, may be mimicking these red Fs. It may be a mimicry system in development going on now as we speak. The big deal again about a dusky is these hind legs are fat compared to the front legs, but look at the salamander on the right, which you're likely to see in the same spot. The hind legs and the front legs are about the same. They've got a black line on the edge of their back on both sides, hence the name. 2-lined salamander. And that's where it gets us. Herpetologists are not known for naming things greatly. There's a green snake that's all green, and we call it, the green snake. How about the black snake? Oh, how about a snake that lives in water? Yeah, let's call it the water snake. How about a salamander with 2 lines on it? The 2 line. How about a salamander with yellow polka dots? Let's call it, the spotted salamander. Anyway, sorry about that. It's a herpetology problem that I don't know how to deal with. These 2-line salamanders are first and second order stream. They also need cold rushing water in which to survive in. And they lay their eggs in communal nesting blobs underneath rocks in the middle of the current of the stream. The females have to go upside down and glue their eggs onto the underside of the rock in the stream channel and lay 5, 10, 20 to 30, and then several females will do the same thing. These take 1 month or 2 to hatch, and they take 2, sometimes 3 years to stay as larvae. If you've got 2-line salamanders, you know you've got a permanent stream. They're very, very cool. So here's what they look like in general. Very, very neat little salamanders. They're about the size of that common forest salamander we have, the redbacks that you all know. But notice the hind legs are not much larger than the front legs on these, and that little dark line you can begin to see on these. Well, these are the two common salamanders. These are larval two-line salamanders that I have, and the reason I want to show you these is that they have small legs, obviously, and tiny little gills. They don't have the big bushy gills that mud puppies had. If they did, they get washed down to the ocean. So they are streamlined, being streamlined. Here's a spotted salamander larvae. Look at how giant those gills are. You put, and the giant tail fin, you put one of these in a stream and they're gone with the wind. They couldn't survive it. So being a stream animal, especially cold water first and second order streams, these animals are really cool. Now they stay on the edges and they will come out at night, feed on small aquatic insects. The larvae, for 2 to 3 years, are feeding on all those other invertebrates that we just mentioned a few seconds ago. And sometimes they'll hike into the forest maybe 100 feet on a rainy night and feed and then come back to the streams. But what I was really telling you about, and this is really the last sort of section, is that we had an unusual situation. A naturalist, from the area who started in 1902 as a 17-year-old kid keeping track of all his birds and flowers that he saw growing up in Essex County on the coast of Massachusetts. Eventually became head of the CCC, reforesting parts of Berkshire County. He then became part of Pleasant Valley Sanctuary. He then took over and ran Bartholomew's Cobble. And until he died in 1962, he kept nearly a weekly, and in many cases 3 to 4 times a week, hand-typed, some of you don't know what a hand typewriter is, on lined paper, and put them all in 3-ring binders. To make a long story short, after he died and his 2 children died, the distant relatives didn't want any of his stuff, and they threw the 17 binders into a dumpster. And Matt Kelly and the Bird Club was able to dive in there and take them out. He gave them to me eventually, and 2 years ago I had a student who had no life and was really focused, and he scanned every single one of those 5,040 pages. He had to do it twice because we needed a different version of the PDF of Acrobat Reader, and he did it. Now, to make a long story shorter, hopefully, Williams College has now accepted the original journals. They're going to have those in their historic library, and they are going to put all of this on the internet. What's the big deal about that? Yesterday, the boys working at Steep Bank Brook at Windsor Park, turning over large stone, uncovered a large pale brown salamander, new to me, 9 inches long, broad and flat of head, protuberant eyes, no gills prominent or noticeable, pale brown in color, lighter along the sides and faintly spotted, suggestive of the sides of a brook trout. The whole presented as a kind of translucent appearance. I almost expected to see its viscera. So pronounced was this condition, tail thick and fleshy. The creature was sluggish of action and not apparently especially fond of the water. This is larger than any salamander with which I'm familiar, if it's out of the range of the mud puppy and the hellbender. And then he wrote in some time later, I think it's the purple salamander. And in fact, that's what it used to be called, the purple salamander, because, close your ears, Jane, if you put them in alcohol when you collect them, they turn purple. It's awful when you're making collections. 1938, Steep Bank Brook, and Ed Newmuth and I and Maya Wiles, a student from Unity College who did a big snake project here in the Berkshires a couple of years ago, I called him and said, hey, I just found where this guy in 1938 had this species. Can we find it again? And we went out and went to that same Steep Bank Brook and we looked. Luckily, Maya, younger than all of us, was able to turn lots of rocks and eventually saw a spring salamander, 8.5 inches long. This is not quite accurate. They are squiggly as hell. We lost it 3 times before we had to turn over more rocks. This is that same purple salamander, now called the spring salamander, thank goodness, Gyronophilis. And this is one of the largest salamanders we have. In fact, the second largest to the mud puppy. They require incredibly cold water, highly oxygenated, because these also lay their eggs, of course, in water, but I've never seen them. I don't know what the eggs of a spring salamander looks like. The places I've looked on the internet, different places, show pictures of two-line salamanders that they claim are gyros, or claim that they're these, and they're not. This salamander lays eggs. The eggs hatch into larvae, and they stay larvae 4 to 6 years before they can ever go out. They're large. They tend to be, some are more orangey than others. They've got a huge fin tail, and they walk on the stream bottom. At night, they're on the edge, and they feed on whatever invertebrates they can get, and they are spectacular. The spring salamander is unique to western Massachusetts. The furthest east I know it from is Palmer, Massachusetts, which is a little unusual. The state was going to list them, and then they started getting records from, me and others. In fact, the state biologist called me a few years ago and said, how widespread are spring salamanders? And I said, I can't find a stream, a first order or a second order stream in the Berkshires where they don't exist. And that's true. I've seen them down at Bashfish Falls and in the brooks on Mount Greylock. Any time of the year, including midwinter, where you saw Bill and Joe going through the ice to find these. They're not listed in Massachusetts, but I guarantee they will be in a few years, because if global climate change continues to affect the brook trout, they're going to affect these small salamanders, these big salamanders, and the little larvae on the edge there. These tiny little things with flat heads have to have these cold mountain streams. Connecticut actually does have these listed as a threatened species. And it's kind of nice to be able to see that just down the line from us, the state of Connecticut does have these things, even though they're probably widespread in Litchfield County. That is all I'm wanted to say about these. Don't ignore these small little streams. Don't ignore the issues of forestry and logging practices, of illegal going across streams. Most people think, oh, who cares about the little streams? The big ones are what matter. You can't have the big ones without the little ones. Over and over again, I will just say that. And so I'll stop sharing this screen now, and if anybody has any questions, or Chelsea, or especially Jane, if you want to add some important things, which I know you could, feel free at all, or I'd be happy to take any questions that people have.
All I have to add at the moment is that was awesome. Thank you so much. It was very
Too nice, Chelsea, too nice. Slimy Sculpin, somebody asked, do they need, I see a couple of questions here, do they need cold water? I've found them in a couple of the tributaries of the Housatonic, but it's cold, fast-moving streams. So it may be less cold and more oxygen they need, but those two are combined. Cold water, and the colder the water, the more oxygen the water can hold. So yes, there are related sculpins, related fish to sculpins that are in larger order rivers, but the slimies are up there for sure. Hi, Lisa, and all the other people I haven't seen in a while out here. Very cute. What role do these salamanders play? Good question, Charlotte. Basically, these are major predators that live on the edge of two separate ecological communities where forests and these mountain streams meet. This edge that they live on, especially the two lines and duskies, and even the adult spring salamanders, they are moving into the forest feeding, they're moving into the streams to reproduce. As they're young, they become major predators on those invertebrates, and they can get to them while the brook trout can't. And even though that dinky little brook trout that I showed you that we found yesterday can get into small crevices, they can't do it as well as the spring salamander larvae. So they are basically top predators in these first and second order streams. At least that's my story for these, and until someone really does a big research project on them. They're studied more in Ontario and Quebec, where they're still common. This is an animal that does get down, in a couple of related species, down the Appalachians, but they're nowhere else except up the Appalachians into southern Canada. You'll find them in Maine, and as I showed you, frozen water, snow has no effect on them. They are there all winter long. The largest number, and the reason I call them top predators is because, as you know, all top predators, whether they're raptors or whatever, they can never have high, dense population numbers. The largest number of spring salamanders I've ever seen on one day is 6 in one small brook in Plainfield. And that was the biggest I've ever seen. And that only happened one day. I go back to that stream regularly, and I've only ever seen, many days I don't see any. Although I never, if I've got Bill and Joe, they won't stop until they see at least one. And so they are, one is our usual discovery. I see Dale asking about the relation of spring salamanders. They are in this giant family called the Plethodontidae, the lungless salamanders. They have no lungs. They could be the poster children for air pollution. Don't do that. They, that was the dumbest thing I've said in days. Well, all right, a couple of hours maybe. So they're related to Duskies and two-lined and redback salamanders. The biggest family of salamanders, in fact, the global center of salamander evolution is the Appalachian Mountains. There are more species there than almost anywhere else in the world. There's a fair number in the Mexico highlands too, but we have a remarkable number. I went down a few years ago with Bill and Joe and Steve Tilley, one of the great salamander experts at Smith College, and we took 10 days and counted something like 67 species of salamanders. And it was remarkable what we could find. Now, some of these look exactly the same to me, and the only way they knew they were different is because they're on that little ridge using first and second order streams. So my message, I hope, again, is to try and suggest that you guys we should all pay more attention to these first order and second order streams. They're hard to navigate, they're tough to get into, even walking the edges. Some of these, they cut through the valleys and make these pretty deep ravines in some areas, and it can be a little difficult to walk, as I'm now beginning to find out in my old age. But that's why we have students and young people. That's why we have Chelsea joining the Berkshire Environmental Action Team. And we can even get Jeff out there and stop yanking up all those exotic invasives at the park and get down looking at some of these. Mark here asked about how far west. Yes, they are in the Catskills. They're in the Adirondacks, and they go, I think you can actually find some species almost to Minnesota. They're more common in the northern part of their range than they are in the south, for sure. Any local resources to recommend to be a good steward? Yeah, the only resource you need is Jane Wynn, who is right there. She puts the fear of God in every state and federal agency that's ever been around. In my view here, Mike, she's right above you, so that's Jane right above. And she is, the Berkshire Environmental Action Team has an incredible database, both in their mind, and also I suspect you're going to start a library in your little spot for published research that would be really helpful to a place I can send my students to, that they could sit there and look at all that stuff. You know, that little brook that is that Maybrook behind your building, or is that what's the other name of that one?
It's not a little brook, it's the southwest branch of the Housatonic River.
Yeah, that dinky little thing is a tributary to the real Housatonic, and Maybrook goes into it, right, from a little further up. That goes the one that goes through our campus at BCC. It's a spectacular little spot, for sure. And yes, it's a dinky little brook, but what does the state dump in there every spring?
I know they jump trout. I hope is it all rainbow and brown?
Yeah, rainbow and brown trout are not native to North America. Brook trout, by the way, have been introduced to Europe and Asia, and they're considered invasive species over there. We're doing this. And I see John Lambert hiding around the corner here, who is probably more knowledgeable about fishes than anybody I know I'll hang around with. I don't hang around with fishermen too much because you all know why. They're strange people. But hi, John, good to see you. Let's see, was there any other questions? So anyway, Mike, really start with beet. But land management is really the big thing, and that has almost certainly cause the decline of a number of these first and second order stream species. And you know, when I see, it really hurts me bad when I see even foresters and loggers are allowed to cross some of these high elevation streams, and they just do such damage downstream. They dig up the mud, it comes down, and that stuff suffocates incredible numbers of critters. It's really sad to see how this goes. If you survey down from a stream crossing where loggers have gone back and forth, you'll find nothing for dozens of meters at all. And so we need to be a little bit better about that. You can't avoid it entirely. I'm not saying it's perfect, but Jane and Bruce will fix it, I'm sure, sooner or later. And Chelsea will probably get stuck out front of it.
Yeah,
I don't want to keep people. Oh, go ahead, Jane. Sorry.
Need to have better legislation that actually protects the first order streams.
And what is the issue about that, Jane? Is there some issues that are happening that we need to worry about?
I don't see anything happening at the moment, but on perennial streams, you actually have the riverfront area going 200 feet on either side, but that is not true on intermittent streams. They don't have that riverfront area. And some conservation commissions are more conscientious about trying to protect it, and some aren't.
Yeah, that's a good point. One of the big issues that you just sort of brought up is this idea of intermittent streams versus permanent streams. And one of the problems is these high elevation streams. I mean, here's something you should do. This is what every interested in nature person should do. Even if you're just a hiker, hike up one of these and find out where the beginning is, where that stream, that that first order stream starts. Look at it. It's a damp little flat area on Greylock or at Savoy Mountain or up in the over in Alander. It's a dinky little place that is slurping water down, and it starts to feed everything downstream. It is, in my opinion, the more important parts of systems that we have not really paid any attention to. And some of these streams will come out, they'll fill with snowmelt and rainwater and all underground water and all that, and then they'll disappear under the ground. And they might pop up a dozen meters later. It's the same stream, but I think I've got a bad feeling, Jane, you're going to tell me that some conservation commissions or state agencies then would call that not a real stream, not a wetland to protect. Is that?
Yeah, if it's dry for, I believe, 5 days, then you can have it declared intermittent. I want a law that says once perennial, always perennial, so that at least if it's perennial upstream, everything downstream of that should be considered perennial, especially here in the Berkshires where, like you said, they go underground frequently.
They sometimes do. And it's really, they're all different. I mean, imagine trying to follow whatever river stream you like and just follow those tributaries. Get up there through the forest and see what it looks like. It's incredible. Even if you drive go up halfway up to Greylock to where Stony Ledge is, and just walk there and look at those beautiful little streamy waterfalls. Oh yeah, follow them up and see what they do. Oh, there's no water coming out of it now. So that is a first order stream. It's got nobody else in there, and you look up there and you'll see two-line salamanders, maybe duskies, and very likely, if you're lucky, the spring salamander, sort of the key to first order streams, in my opinion. So that's what it is. All right. Chelsea, anything else that we need to do or say, or group hug or whatever it is?
So someone actually just asked a question, and I have a few as well if nobody has any others to throw out after this. But is this combination of streams considered watershed? Are there watershed protections? And that came from Charlotte.
Yeah, Jane's better to answer that, but that whole bunch of branches that all flow into each other, that flow into a main stream that goes into the ocean is a single watershed. And so that first picture I showed you, or may have shown you, of the Westfield River system, that watershed is everywhere. Now, how do you divide one watershed from another? How do you know? And if you're not an adult, or if you're too pleasant, if you're too nice of a person, don't listen to this. What John Lambert taught me. send a student up to Mount, no, it was Bruce. He sent a student on top of Greylock. If you pee on the north side of it, you are peeing into the Hudson River drainage. If you pee on the other side, it's going into the Housatonic River. In fact, if you drive up, that woke everybody up. This will be the last thing you ever have Chelsea do, I'm sure. If you drive up Route 7 towards Williamstown, what direction does that river flow? What direction does the Green River flow? It's flowing north. That's not right. Well, it's flowing downhill, and that's why North Adams and especially Williamstown has an average temperature of 4 to 6 degrees warmer than the rest of us in Berkshire County, even warmer than down in Great Barrington. It's flowing down slope, but it's going out here. It's turning left into Williamstown to the Hoosic, into whatever that state is. Oh yeah, New York, hits Vermont, then goes into New York, and goes into the Hudson River. The divide between these is called a divide. There are divides that separate. The Great Divide, we got a bunch of great divides. They're little divides. I won't even call them dividends. I don't know what you would call them, little dividers, dividettes. But every watershed is a unique ecological entity that every single drop of water that comes out of a critter, out of the sky, out of melting snow, all has the potential to flow into that main branch and eventually into the ocean. So they are unique, separated ecological communities, every single one of them. And we've got at least 4 in Berkshire County. 4 divides. Oh, the Housatonic River. Oh, Jane's counting, said, I'll bet she does it. And the Housatonic River, and John did teach me this, has one branch up by the ski slope up there. Where the hell is that ski slope? And then 2 others over on the east side of the Berkshires. These streams come down and hit at Pontuzic. It's the beginning, but that's not the headwaters. The headwaters are up the hills. Go hug them. Go find them. See where your life begins. Oh boy, that was dramatic. Chelsea, help me out of here. Just give me another question quick.
Does anybody else have any other questions? No. Okay. I was wondering, are the Strahler and the Shreve methods, are they valuable in different ways? Because you said they're both valuable, but the Shreve seems to make more sense to me.
Well, it makes more sense to different people. So in GIS mapping, both of them, you have a choice of doing the Shreve or the Strailer method. But the Shreve method, no, the Strailer method has more predictability when you're doing coming up with different guesses on what might happen to this stream if the water changes over here, if the rainfall changes here. It's better for doing just what I'm trying to say, word Brusco, he could tell me, just monitoring, not actual monitoring the field, but doing measuring on a computer. It will give you the best information there. The Shreve method is actually, some people like that better because it really does tell you how many streams are above you, are uphill from you, are upstream from you, because the Strailer method doesn't. It's just either 1, 2, or 3 at the most. But the other one just keeps adding these, so you can actually tell how many more brooks or streams or cold water entities are above you. So it really depends. They're both used heavily. The 2 other methods, one in the 1800s, one in the 1930s, are sometimes used as well, but not nearly as much. Nowhere that you go doesn't have a first order or second order stream somewhere that's causing everything. Not causing, contributing to everything. Sorry, Chelsea. Jane, did you want to add to that? Because I think you know more about this than I ever will.
Nope.
Well, John, how about you? You're a stream kind of guy. No, he's chickening out. I don't blame him. What else, Chelsea?
When you said the Amazon River is a 12, is that for Strailer?
Yes. Well, it's actually almost both of them, but it's Strailer. And it's really kind of weird because when I've taken students, luckily several times, to the Amazon in Peru, we are at the confluence of 2 or 3 major rivers that are the headwaters of the Amazon. And where we are in Peru, it's about 2,000 miles to the ocean, and yet the elevation is only about 800 feet. 2,000 miles and 800 feet. It is a low mother. And when you think people around here complain when the Housatonic overflows its banks and you get a little, the Amazon, at least in parts of it, when it floods 20 to 30 miles on either direction. It's an incredible watershed that is incredibly flat. That, of course, is the big difference between the Housatonic River, the Hoosic River, the Connecticut River, is when you get to be these big 3rd, 5th, 6th, 8th order rivers, you're in really flat land. You're meandering you're doing big meanders. It's a slower current. Everything is different, often deeper water, and it's silty. It's not the same.
Interesting. So what stream order constitutes a river?
It depends on how many tributaries. So the west branch of the Housatonic will have 2 or 3 tributaries coming into it. In fact, I don't know. Bruce will find out with his students who need extra credit because they're studying parts of May Brook now. And it would be really neat to actually know how many are there. So each tributary can have an order based on how many are up there, if that wasn't clear. So it depends on how far away and that's sort of the second method. It sort of gives you a hint of the distance between the mouth of the river and its original cold water 1 and 2 order streams. That is a much more likely way to sort of guess the extent of a watershed.
Okay.
The Strailer Method, not so much.
Okay, thank you. I have a couple more, but I don't want to keep everyone and
That's all right. I see a note from Therese who said, would I mind sending me a picture of some eggs? No, send them on. You can send them to Beat and they'll send them to me, or just Tyning at Berkshire Community Club. Berkshire, what the heck is our email? Tyning at berkshirecc.edu. And I'd be happy to see those those eggs. Who knows what in the world they'd be. But if they're on the edge of a
salamander,
pool,
but I wouldn't put my money on it.
darn, I was hoping to make some from that. For Beat, of course. All right. Have we had as much fun as we can take, Chelsea?
Does anyone have any other questions or comments?
Go ahead, Chelsea.
Oh, I don't want to see everyone. If anything, I can annoy Tom or ask Jane or Google it, I guess. I don't know.
I never get annoyed. Sometimes never.
Thank you, everyone, for being here. And thank you so much, Tom, for taking the time. It was really awesome and just very informative. Learned a lot.
Thanks for inviting me, and it's great to see all of my friends.
Right.
Hasta la pasta.
Good night, everyone.